Hello everyone, this is a free scale development kit. We have used this kit to develop a program for cruise control of a car. The potentiometer on the free scale kit represents the accelerator pedal of a car, and the input from this potentiometer is used to drive the DC motor. The DC motor represents the wheel of a car, and we have mounted an optical disc onto the DC motor to note down the speed at which the DC motor is spinning. The optical encoder generates a square signal based on the reflection from the wheel, and the square signal is fed into the timer input capture, and we use it to calculate the RPS, that is revolutions per second, of the DC motor. This switch is used to turn on the cruise control. The push buttons 1 and 2 are used to increase and decrease the speed of the DC motor by 5 RPS while the cruise control is in operation. When the cruise control is turned off, the control is returned back to the potentiometer. As the pulse width modulation signal cannot be directly used to drive the DC motor, an NPN transistor is used to act as a switch. The pulse width modulation signal is connected to the base of the transistor.
Yeah, the speed of the DC motor is controlled using the input from the potentiometer. As you can see, I'm giving input from the potentiometer. The motor is turned on. The value of F represents the revolutions per second of the motor while it's not in cruise control mode. Currently it's around 45. Now we turn the cruise control on, so the value of the RPM is taken into account at that instant when the cruise control is turned on and used as a reference, and that value is fed into a PID controller, which in turn uses a pulse width modulation signal to drive the motor. As you can see, we can set the potentiometer to 0 now. This does not drive the system right now. It's driving on its own using the reference value. As you can see, the RPM is 48 and it's currently maintaining that RPM. These buttons can be used to increase the speed or decrease the speed by 5 revolutions per second while it's operating in the cruise control mode. I'm pressing it twice. It should have an increase of 10 revolutions per second. Now the revolutions per second is 58. Previously it was 48 and we had pressed it twice to have a jump of 10 revolutions per second. Now it can also be reduced by using the second button. I'm pressing it 3-4 times. Now it will be reduced by 20 revolutions per second. You can see revolutions per second is around 37 now. We can also switch it back to the control mode by turning off the cruise control switch. Now the motor runs from the input from the potentiometer. You can use that to alternate the speed of the motor. You can use it to increase the speed of the motor. So the cruise control system can be turned on again, as you can see, and it maintains the same speed. You can turn off the input from the potentiometer, and the feedback from the optical encoder is used as the reference, and that speed is maintained continuously.